Hello students, I am Satitrakar. Welcome to Cars Physics. We are continuing current electricity, chapter number 3, class 12. In this lecture, we are going to start a conceptual discussion, that is combination of cells. Combination of cells. So previously you have already studied, we have discussed combination of capacitors and combination of resistors. Similarly here, we will study combination of cells. So cells may be combined in different ways. So basic type of combination of cells are cells in series and cells in parallel. Cells in series and cells in parallel. And finally, mixed combination of cells means where there is both combination. There are both combinations means in series and in parallel. If both combinations are present in a circuit containing a number of cells, then the cells are said to be in mixed combination. Okay. Then why do we combine cells in different ways? Why do we combine cells in different ways? So, cells may be combined in series or in parallel or in mixed combination. So, cells are combined in series. Cells are combined in series to get maximum voltage. Cells are combined in series to get maximum voltage. Okay, and we know units of EMF is volt, units of potential difference is also volt. Volt means or EMF means source of energy. Okay, so cells in series, if a number of cells combined in series, then we can draw or we can get maximum voltage. Then cells in parallel. When a number of cells are combined in parallel, then what output may be available? Cells are connected in parallel to get maximum current. Cells are combined in parallel to get maximum current, and finally mixed combination of cells. So where there is a series and also parallel combination of cells, then the cells are said to be in mixed combination. Okay, and cells are combined both in series and parallel means in mixed grouping to get maximum power. Okay, so cells are connected in series or combined in series to get maximum voltage. Cells are combined in parallel to get maximum current, and in mixed combination of cells we can get maximum power from the combination. Okay. So this lecture means on combination of cells may be a very long discussion, and I did decide that I will discuss all these three combinations, series, parallel and mixed combination of cells, by dividing the lectures, so that we can discuss all the conceptual points, and also we can separately discuss the numericals on the basis of cells in series, cells in parallel and mixed grouping of cells. Okay. So if once you get clarified the fundamentals or the basic thoughts, then nothing will be difficult for you. Keep it in your mind. If your fundamental is clarified, and if you understand the theory, if you feel the theory, feel the concept, and know how to apply the concepts in numericals, then no numerical will be difficult, for you. No numerical will be difficult for you. Just understand the concept and apply the concepts in questions and also in numericals. Let's start our discussion cells in series. In this lecture, we will discuss all the concepts related to cells in series, and finally will appear some fundamental numericals which may be applied to your board base as well as for competitive base. Okay. And I hope this lecture will be highly helpful for you. Okay. Our first discussion, cells in series. Series combination of cells. Okay. Have attention and you keep your pen and paper ready. You may note it or you may pause the video and try the numericals. Finally, we will appear numericals. We will approach numericals. Okay. Cells in series. First I am writing the fundamental definition of correct combination of cells in series. Correct combination. And then we will go to wrong combination of the cells in series. Cells in series, when correct combination in series. If negative terminal of first cell, is connected to positive terminal of second cell and so on. So a number of cells, you may use 2 cells, you may use 3 cells, or you may use a number of cells. A number of cells are said to be connected or combined in series if negative terminal of first cell is connected to positive terminal of second cell. So symbolically you may write negative terminal connected positive terminal, negative positive and so on. Negative terminal of first cell should be connected to positive terminal of second cell and so on. Okay. Suppose we are using 2 cells. Let's start discussion from 2 cells. So 2 cells are connected in series. This is first cell, this is second cell. Let EMF of the first cell is E1, EMF of second cell is E2, and similar. Internal resistance of first cell R1, internal resistance of second cell is R. This is correct combination. Negative terminal of first cell is connected to positive terminal of second cell and so on. Okay, means we may connect here the third cell, positive, negative, EMF is and internal resistance R. Okay, negative, positive, negative, positive, negative, positive and so on. Okay. So, negative terminal of first cell is connected to positive terminal of second cell. Negative terminal of second cell is connected to positive terminal of third cell and so on. This is correct combination of cells in series. Okay. Then how to get equivalent EMF? Suppose, for a short discussion, let's consider two cells. In similar ways, we may calculate. Two cells are connected in series. Then we may find now equivalent EMF and equivalent internal resistance. Let's combine the cells to get a single cell. Let's add in like this. Okay? Two cells. The combination of two cells will give a resulting cell. Okay? This is combination of two cells, and here this is E equivalent, means equivalent EMF. And this is internal resistance are equivalent, positive, negative. Then what will be the expression for equivalent EMF for two cells combined in series here? Equivalent EMF will be E1 plus E2. Okay? EMF E1, EMF E2, sum of EMFs E1 and E2. And equivalent resistance, of course, R1 plus R2. And we know the formula for equivalent resistance in series R1 plus R2 plus R3 and so on. So here there are two resistors, internal resistors. So both are in series, so equivalent internal resistance is R1 plus R2. Okay. Why? Okay. Okay. I will discuss why. Why I write this expression. Answer is there. Suppose this end is A, this end is B, A and B. Two cells are connected between A and B. You may assume this is part of circuit. This is part of a circuit. Means current is flowing in this part of circuit. If this is a part of circuit, then current is flowing. Okay. Current flows in this direction. Let I is current. Let I is current. Let I is current. In series, of course, current remains same. We know. In series, current remains same. Two end points are A and B. Let's consider this is intermediate point. This is intermediate point C. And the previous expression, you know, potential difference V is equal to E minus IR. When the cell discharges, okay, when the cell discharges, then potential difference means terminal potential difference is E minus I. So this is positive terminal for first cell connected to A. This is the negative terminal of first cell connected to C. Then potential difference between A and C, in place of V, potential difference I can write VA minus VC. Potential difference V, here VA minus VC, and this is equals to E minus IR between A and C. EMF is E1, current is I, resistance is R1. So E1 minus IR1, E1 minus IR1. Similar, potential difference between C and B. Let's consider this part. Potential difference between C and B. In place of B, I do write VC minus VB. That's equals to here EMF is E2. Again, current is R. Internal resistance is R2. Now let's combine these two equations. Just add these two equations. V minus VC plus VC minus VB. Then add right side E1 minus IR1 plus E2 minus IR2. See, VC get cancelled. VC get cancelled. Then potential at A minus potential at B is equal to E1 plus E2 E1 plus E2 minus IR1 minus IR2. Bring minus I comma. minus I. So inside bracket R1 plus R2. See. Then VA minus VB, VA minus VB, let's write V. V is equal to E1 plus E2 minus I R1 plus R2. Okay. I am writing the expression here. Potential difference between A and B. Potential difference VA minus VB. Difference between A and B is V. V is equal to E1 plus E2 minus I into R1 plus R2. Let's compare this equation with V is equal to E minus I. Compare this equation with V is equal to E minus I. So here, in place of E, we are getting, in place of E, EMF, we are getting resulting EMF E1 plus E2. So, equivalent EMF is E1 plus E2 and IR. In place of R, we do get R1 plus R2. Means here, equivalent internal resistance is R1 plus R2. This is the equivalent cell of EMF E equivalent, and internal resistance R equivalent. Equivalent EMF is E1 plus E2. Equivalent internal resistance is R1 plus R2. Is it clear? Okay. Or simply you may apply Kirchhoff's law for this part of circuit. I am showing you. Or simply you may apply Kirchhoff's law for this part of circuit, and again result will be same. Say this point is a positive, negative, internal resistance R1, EMF E2, positive, negative, internal resistance is R2. Between A and B, there are two cells. Current is flowing, I. Current is same in series. Then what is direction of flow of conventional current? What is direction of flow of conventional current? Conventional current flows from high potential to low potential. So current is flowing, current will flow through this internal resistor which is inside the cell. Then flow of current is always from high to low. Flow of current is always from high to low. Just apply Kirchhoff's law to this part of circuit A, B. Part of circuit is A. Then start from A. Potential at A, V. We are moving from A towards B, and you know, sign convention from high potential to low potential. From high potential to low potential, sign we have taken negative. From low potential to high potential, we are taking positive sign. Okay. Convention, this is convention or vice versa. We do have accepted this. From high potential to low potential, negative. From low potential to high potential is positive. Okay. Then from point A, at point A potential is V. Then EMF E1, we are traveling or we are moving from A to B. First positive, then negative, high potential, low potential, minus E1. Then about the potential drop in the internal resistance. So current flows from high potential to low potential. We are moving opposite to the direction of current, means from low potential to high potential. So here potential drop is plus IR1, low potential to high potential. Opposite to the direction of flow of current means low potential to high potential. For this internal resistor, potential drop is positive, from low to high positive. current is I, internal resistance is R1. Then comes C2. Again from high potential to low potential towards B, minus C2. So for this internal resistor, we are traveling, we are moving opposite to the direction of flow of current, means from low potential to high potential plus IR2. IR2 is equal to potential at B. So this is in accordance with Kirchhoff's second one. Okay. Total change in volt in a closed path of circuit is 0. We have considered this part of circuit, bring VV to this side, and total sum will be 0. So VA minus VB, bring VB to this side and all these to right side. VA minus VB, E1 plus E2 minus IR1 minus IR. E1 plus E2 minus IR1 minus IR. So VA minus VB, let's take V. Potential difference is V, and here again E1 plus E2 minus I. Again you see the same result. Equivalent EMF is E1 plus E2. Okay, and equivalent internal resistance is R1 plus R2. This is about correct combination of cells. Okay, so if you take this is E, this is E, then equivalent EMF will be 2E. Equivalent EMF will be 2E. If internal resistance is same R and R, then equivalent internal resistance is 2R. Okay. Suppose you take 3 cells in correct combination, then E plus E plus E, 3. Internal resistance is R1 plus R2 plus R3 to get equivalent internal resistance. This is the concept. Very easy. Okay. Then let's discuss about wrong combination of cells. Okay. Cells in series. Cells in series. Wrong combination of cells. Okay, see. This is first cell. This is first cell of EMF E1, internal resistance R1. Then what is correct combination? Negative terminal of first cell. Negative terminal of first cell should be connected to positive terminal of second cell. So that equivalent EMF is E1 plus E2. See, this is our correct combination. This is E2, positive, negative. So negative terminal of first cell connected to positive terminal of second cell. This is correct combination. Right combination. So what is wrong combination? Just reverse the polarity of any cell. Just reverse the polarity of any cell. Suppose I do reverse the polarities of cell, second cell having EMF E2. Okay. Then the internal resistance is R. Polarities are reversed. This is negative. This is positive. Polarities of the cell is reversed, means here negative terminal of first cell is connected to negative terminal of second cell. So negative terminal of first cell should be connected to positive terminal of second cell. Here negative terminal of first cell is connected to negative terminal of second cell. This is wrong combination, means polarities of the second cell is reversed. Polarities are reversed. So this is wrong combination. And here, if you make an equivalent cell between A and B, condition is if E1 greater than E2. If E1 greater than E2, then here equivalent EMF will be E1 minus E2, and equivalent internal resistance of V3 R1 plus R2, since resistance is in series, just we do take algebraic sum of resistances. Okay. So here equivalent EMF is E1 minus E2. What? Okay. Why? Very simple. Why? I will answer. In similar way, you may apply Kirchhoff's law. Just apply Kirchhoff's law. Okay. Current I. Current I. Let's flow of current in this direction. Okay. For a part of circuit, we may take convention. Okay. This is flow of current. Then potential at A. Let's take B. Let's move towards B. In this direction means opposite to the flow, direction of flow of current. While moving from A to B, to overcome this EMF, we are traveling from high potential to low potential minus E1. Again, for this internal resistance means to get potential drop, we are moving from A to B. Means for this resistor, this is high potential, this is low potential. Current flows from high potential to low potential, and we are moving opposite to the direction of flow of current, means from low potential to high potential plus IR. And again for this, we are moving for resistor R to internal resistor R2. Again we are moving opposite to the direction of flow of conventional current, means from low potential to high potential plus IR. Then for this EMF, we are moving from A to B. This is negative terminal, this is positive terminal, means we are moving from low potential to high potential plus E2 is equal to potential at B. V. Then finally, VA minus VB is equal to, take all these to right side, E1 minus IR1 minus IR2 minus E. Then VA minus VB, potential difference between A and B, let's take V, and this is equals to E1 minus E2, E1 minus E2, and minus I bring it common, R1 plus R. So, if E1 greater than E2, then equivalent EMF, we are getting E1 minus E2, and equivalent internal resistance is same R1 plus R. Convinced? Okay. So, if E2 greater than E1, suppose E2 is greater than E1, then equivalent EMF will be E2 minus E1. If E1 greater than E2, then E1 minus E2. If E2 greater than E1, then E2 minus E1 is equivalent EMF. Okay. So let's analyze this round combination properly. Okay. Suppose let's take three cells, three identical cells. See, this is correct combination. Negative terminal of first cell is connected to positive terminal of second cell. Negative terminal of second cell is connected to positive terminal of third cell, and we have taken equal values of EMF, means identical cells of same EMF and same internal resistance we have considered. Then This is R equivalent, this is E equivalent. Then as per our discussion, if the cells are connected correctly, then equivalent EMF is E plus E plus E means 3. E1 plus E2 plus E3 for correct combination. Means here E plus E3 and equivalent internal resistance is R plus R is equal to 3. This is for correct combination. Okay. For wrong combination, let polarities of any one of the cell is reversed. Polarity of any one of the cell is reversed. Okay. So just make it wrong combination. So let's reverse polarity of this second cell. Then this way, internal resistance, negative connected to negative, negative terminal of first cell connected to negative terminal of second cell. This is wrong combination. Okay. Then what we will do? Equivalent EMF is equal to E. Polarity is reversed, minus E plus E. Polarity of second cell is reversed, so take it negative. Then R equivalent is, there will be no change, R plus R, that's equals to 3R in series. But here, equivalent EMF is E, means EMF due to a single cell. 3 cells are connected in series. If one cell is wrongly connected, then equivalent EMF is due to a single cell out of 3 cells. This is the concept. Okay. Then we'll find a fundamental formula for this. Let's see. Equivalent EMF, see here. N is the number of cells in series. N is the number of cells. I am writing completely. Let N is number of cells in series. N is the number of cells in series and N is smaller. N is number of cells wrongly connected. Means for n number of cells, polarities are reversed. We have taken 3 cells. So number of cells is 3. Here n is equal to 3. Here n is equal to 3 total number of cells and n is equal to 1. One cell is wrongly connected. Then equivalent EMF is E. Then what is the generalized formula? E equivalent for wrong combination. For wrong combination, E equivalent is, we'll write like this. N minus 2n into E divided by this much. Equivalent EMF will be N minus 2n into EMF of any cell, since the cells are identical. All the cells of equal value of EMF E. Then N minus 2n into E. Let's see, check it. Here N is 3 minus 2. Number of cells wrongly connected is 1. 2 into 1 into E. See, result is E. Result is E. See, if one cell, means if polarities of a single cell is reversed, then it may affect to another cell. It may affect to another cell. Minus E plus E or minus E plus E. Then we are getting EMF due to a single cell. Similarly, suppose just use this formula. Just use this formula. Suppose I am taking 6 number of cells. 1, let's consider 6 identical cells, each of EMF E and internal resistance is R. These cells are in correct combination. Negative, positive, positive, negative. Negative terminal of first cell is connected to positive terminal of second cell and so on. This is correct combination. Then equivalent EMF is 6 because here N is 6, number of cells is 6 and equivalent internal resistance is 6 R plus R plus R. Okay. Then if suppose 2 cells are wrongly connected, negative, positive, polarities are reversed. These 2 cells are wrongly connected, then what will be the value of the equivalent EMF? E equivalent. Just use this formula. Number of cells is 6 in place of N, that is 6. Minus 2 into N, small n means number of cells wrongly connected. Here 2 cells are wrongly connected, into 2 into E. Then this will come 6 minus 4, 2. If the cells were correctly connected, then equivalent EMF would be 6E. If 2 cells are wrongly connected, then equivalent EMF of 6 cells, 6 identical cells is 2E, means EMF due to 2 cells. This is the concept. So just keep it in mind. We'll see some other range of numericals after completing the theory. Okay. The next concept, what type of cells should be connected in series? Today we complete total fundamental on series combination of cells. What type of cells should be connected in series? Let's consider n number of cells. Let's consider n number of cells are connected in series. Correct combination? 1, 2, n number of cells. Positive, negative, positive, negative, positive, negative. Total number of cells is n. Each cell of EMF E and internal resistance R. Circuit is completed with external resistance R. Then obviously current will flow in this direction. Current will flow from high potential to low potential. Then let's find what is effective current or equivalent current in the total circuit. Make the equivalent circuit E equivalent, and here you may take R equivalent. This is external resistance, less current is effective current or equivalent current in this circuit is IE. Let. Okay. Then E equivalent. N number of cells are there, n number of cells, each of EMF E, then each cell, EMF of each cell are R. Then equivalent EMF is N and equivalent internal resistance R plus R up to N, that is LR. And total current in the circuit is E equivalent, that is equals to E equivalent divided by external resistance plus total internal resistance. E equivalent divided by total resistance, external resistance plus internal resistance. Since both external and internal resistances in series. Then equivalent current is E equivalent. What is value of E equivalent? N divided by external resistance R plus R equivalent is. This is formula for total current in the circuit. This is formula for equivalent current, sorry, effective current in the circuit, that is NE by R plus NR. Then what type of cells should be connected in series? Okay. Can I erase this? You know the equivalent circuit we have already discussed. Okay. First bit. NE and the equivalent internal resistance is NR. Total EMF is NE, total internal resistance is NR, and external resistance is R. First we see external resistance is much more as compared to total internal resistance. If external resistance is very high, much more as compared to internal resistance, then this formula R is greater than NR, means in this case internal resistance of cell is very small. Internal resistance is very small as compared to external resistance. Then we may neglect this. If the internal resistance is very small, then we may neglect this factor. Then effective current is NE divided by R. This factor is neglected. Then this is N into E by R. E is in volt, R is in ohm. So volt by ohm is ampere, means current. So we may write it. So I, if a single cell, means if you neglect the internal resistance, means if a cell is connected with an external resistance, internal resistance is neglected, then E by R is I, means current due to a single cell, and total current is NI. N times current due to a single cell. So second bit, if external resistance is very small as compared to internal resistance, means in this case, internal resistance of the cell is very high, so that external resistance may be neglected. Then equivalent current, NE, this R is very small, neglect external resistance divided by NR, NN get cancelled. So if there is no external resistance in a circuit, neglecting external resistance, internal resistance is R. So EMF divided by resistance is current due to a single cell. Current due to a single cell. So this type of cells should be connected in series so as to get maximum current. Okay, but in series we do get high value of voltage, NE. NE means maximum value of voltage is obtained from series grouping. So if external resistance is very high as compared to internal resistance, then total current is N times the current due to single cell. If the external resistance is much less as compared to internal resistance, then effective current in the circuit is due to a single cell. Conceptual point, graphical representation which may appear in objective range questions. Okay. So for this, effective current directly depends upon number of cells. Effective current directly depends upon number of cells. N is the number of cells if external resistance is much more as compared to internal resistance. So current increases by increasing number of cells, but here current is independent of N, means here IE is independent of n. Of n means number of cells in series. So the variation between current and number of cells, in this case, if external resistance is very small as compared to internal resistance, then this is the representation means variation of current with the number of cells means there will be no change in current. Current is independent of number of cells, but here current increases with increase in number of cells. Here current is independent of number of cells. This is total theoretical concept. Okay. Let's appear some numericals which may be useful for your board level and some questions for your competitive level. Okay. Let's start from very simple example. Question number 1. Positive, negative. Let this is 3 volt. Internal resistance is 1 ohm. Between A and B there are 3 cells in series and all the cells are combined correctly. Negative, positive, okay, 3 cells. Then this is equivalent representation, E equivalent and internal resistance equivalent. E equivalent is 3 volt plus 4 volt plus 6 volt, that is equals to 13 volt, and equivalent internal resistance 1 ohm plus 2 ohm plus 3 ohm, that is 6 ohm. Very simple. Next, let's approach some numericals and it will be beneficial for you. Okay. Question number 2. That we have discussed this theory. Okay. N number of identical cells means each of EMF E and internal resistance are n number of identical cells each of EMF E and internal resistance are connected in series, and n number of cells are wrongly connected. The circuit contains an external resistance R. Circuit contains external resistance R, then we have to find current in the circuit. What is total current in the circuit? Then let's find what is equivalent EMF in the circuit. And as per our formula, n minus 2n into E. If n number of cells are wrongly connected, capital N, n is the number of total cells in correct combination of cells, and n number of cells are wrongly connected, then equivalent EMF is n minus 2n into E. Complete. Then what is total current? See. This is E equivalent. Okay. This is R equivalent. And finally, this is external resistance, this is current. Then R equivalent is enough cells in series. Okay. So resistance is internal resistance is in series. So then current is E equivalent means n minus 2n into E. divided by total resistance, external resistance and internal resistance. Internal resistance is NR. Since both the resistances, internal and external resistance, total internal resistance and external resistance in series. So this is our answer. It may come in objective base with different options. N minus 2n into E divided by R plus NR. N plus 2n into E divided by R plus NR. N minus E divided by R plus NR. Different options will be there. Just go through the fundamental. Next question. Next question. This will be a conceptual question. Have attention. This may appear in competitive range exams. Question number 3. 19 cells. Okay. 19 cells identical. 19 identical cells, each of EMF E and internal resistance, let's assign a value, and internal resistance 0.1 ohm, each of EMF E and internal resistance 0.1 ohm connected with an external resistance. Current in the circuit is 2 ampere. 19 number of identical cells, each of EMF E, internal resistance 0.1 ohm with an external resistance. Current in the circuit is found to be 2 ampere. Now, if 15 number of such cells are, all these are in series, we are discussing only on series combination of cells. Now, if 15 number of such cells are used with an additional external resistance, let's assign a value 9.5 ohm, then current becomes 1 ampere. See, if 15 number of such cells are used with an additional external resistance of 9.5 ohm, then current becomes 1 ampere. Find EMF of each cell and external resistance first used. External resistance first used. See, in first case, with an external resistance, we have to find this value of external resistance and what is EMF of each cell. This is the concept. Note down the questions and try it once. You may pause the video and try it once. Okay. I am doing the equivalent circuit. This is for first case, this is for second case. In first case, 19 identical cells, then total EMF is 19, E plus E after 19, and this is R equivalent, means 19 into R with an external resistance. Let external resistance is R1, which you have to find, and current is I. Okay. Then equation, as we know, I is equal to E equivalent divided by R plus NR in series grouping. Equivalent EMF divided by external resistance plus total internal resistance, as here. I1 is equal to equivalent EMF 19, external resistance R1 plus internal resistance 19 into R, and I1 is given 2 ampere. This is 2, 19 divided by R1 plus, here we may write 19E divided by R1 plus 19 into external resistance is 0.1, means R1 plus 1.9. This is from first case and from second case. From second case, now we are using 15 number of such cells, means EMF and internal resistance cell. 15 number of such cells. This is 15 E plus E plus E up to 15, and this is R equivalent 15 R. Previously there was an external resistance R1 which we have already used. Now another additional external resistance of 9.5 ohm is used. Now current is I, and I2 is equal to equivalent EMF 15 divided by total external resistance in place of R. These two resistances in series, so total external resistance R1 plus 9.5 plus total internal resistance 15 into R. So I2, in place of I2 we may take 1 ampere, that is equal to 15 divided by R1 plus 9.5. Again internal resistance is 0.1, so plus 1.5. 15 into R, in place of R 0.1 ohm, which is value of the internal resistance, and this is second equation, means from this given data. Now we have to solve for E and R. Now we have to solve for E and R. Can I erase the top part? Okay. Now solving these two equations, just divide these two equations. Just divide, you will get your answer. Okay. And 2 divided by 1, divide left side, 2 divided by 1, this is equals to 19E, here 19E divided by R1 plus 1.9 divided by 15E, divided by 15E, R1 plus 9.5 plus 1.5, 9.5 plus 1.5, this will come 11. Then this is 2. 19 E gets cancelled, E gets cancelled. So 19 divided by 15 in R plus 11 divided by, R1 plus 11 plus R1 plus 1.9, just solve it. Okay. We have got the equations, then solving. 15 into 2, 30. Just multiply this, 30 into R1 plus 1.9 is equal to 19 into R1 plus 11. Now only solve 30 R1, 30 R1 plus 19 into 3, 57, 0. Okay, again it will come 57. 19, 30 into 19, 19 into 3, 57. Then this is 19 R1 plus 19 into 11 plus 19 into 11, it will come 9, 20. 209, 209 will come. Now solve it. 30 R1 minus 19 R1 is equal to 209, 209 minus 57, 209 minus 57, this is 2, this will be 5, and this is 1. Okay. 209 minus 57 is 152, and this will come 11 R1. 11 R1 is equal to 152, then R1 is equal to 152 divided by 11, 152 divided by 11, and it will come 13.8 ohm. We have got value of R1. We have got value of R1. Now you can calculate using any equation. Means you can calculate the The next factor is EMF is asked. You just take this equation. We may use here. 1 is equal to 15 divided by R1. R1 is 13.8 plus 9.5 plus 1.5. Solving it, you will get EMF is equal to 1.65 volt. These are our answers. Just half this fundamental. It will be applicable in future. Okay. Last question. Okay. Last question is very interesting and a common question also. Question is given n identical cells, each of EMF 6 volt, each of EMF 6 volt are connected to the ends of external resistance of 5 ohm and current found to be 10 ampere. In identical cells, each of EMF 6 volt are connected to the ends of an external resistance of 5 ohm and current found to be 10 ampere. Now, if two cells are wrongly connected, current becomes, if two cells are wrongly connected, current becomes 6 ampere. Find value of A. How many number of cells? Find value of A and internal resistance of each cell. Find number of cells in series and internal resistance of each cell. Then let's consider first case. Total number of cells is N, EMF is 6 volt. Then current is I1, N. All these cells are correctly combined. N divided by R plus N as per our previous formula. And I, in this case, current is found to be 10 ampere. N, in place of E, we can write 6 N divided by external resistance 5 ohm plus N into R. This is equation 1. Then in second case, two cells are wrongly connected. Then in this case, current is I and equivalent EMF N minus 2N into E, N minus 2N into E, N minus 2N into E, equivalent EMF divided by external resistance plus total internal resistance. Okay. Then current is 6 ampere. N minus 2. Two cells are wrongly connected. Means here small n is 2 into E divided by external resistance is 5 ohm plus N. Then from this we get 6 is equal to N minus 4 into E divided by 5 plus N. This is from first case. This is from second case. Now it is made easier. Just solve it. Divide these two equations. This is first equation. This is second equation. 10 divided by 6. Similar way, 10 divided by 6. Left side is divided. Then 6n divided by 5 plus n divided by n minus 4 into E divided by 5 plus n. 5 plus n get cancelled. Then 10 by 3, 5 by 3. Sorry, 10 by 6 is 5 by 3 and we get 6n divided by n minus 4 into E. n minus 4 into E. But EMF is given, put here 6. EMF is given 6, 6 get cancelled. Now solve it. 5n minus 20, 5n minus 20 is equal to 3. 5n minus 3n, 2n, 20 is equal to 20. The number of cells is 10. Number of cells is 10. Then putting this value n in any equation, say put here. 10 is equal to 6 into 10. In place of n, we may take 10 divided by 5 plus. Then 5 plus 10 is equal to 60 divided by 10 means 6. 10 get cancelled 6. This is 5. Then 5 plus n is 10, 10r is equal to 6. So 10r is equal to 1. R is equal to 1 by 10 or 0.1 ohm. This is our answer. Too easy. Just understand the concept and apply in numericals. Thank you. Thank you, my dear children. Thanks for your sincere cooperation. Thanks.